Hi, my name is Cheng. I work on the platform team at the advisory board company. For over 30 years, we've been helping hospitals improve healthcare in the US. And today, what I want to talk about is how we're using big data as part of that mission. But before I get to that, let me ask you a question. Does big data actually lead to big results? We asked hospital executives at over 2,000 hospitals. They all had this question, but no good answers. And you need only look at the changing healthcare landscape to see this big data opportunity coming. We are creating data like never before. There is more and more and more of it. But the question is, do you actually have to wait for it to get any useful insight? Because if that is your intention, here is what you're going to do. You're going to collect that data, you're going to collect it some more, and you're going to hope that somewhere in this big pile of data, you have a gem of insight, something that you can do something with. But I want to share a secret with you. You don't have to do that. What you need to do is to actually find actionable insight in the data that you already have. Don't just collect data to have it. Action is what leads to results. Time to market trumps completeness. So let me give you an example of this. In the election of 2012, 200,000 voters decided this election. And the race between the campaigns was to see who could spend $1 billion of TV money to most effectively target these voters. And it's here that something absolutely amazing happened. The Dish Network was able to start offering much more detailed viewer demographics than ever before. If you wanted a 25-year-old male with one car and no kids, they were watching Adult Swim at 10:45. Now, that data amounted to maybe 3% of all the viewers in the United States. And yet 3% was good enough for a trend that the Obama campaign used to significantly underspend the competition for every voter they reached. Time to market trumps completeness. Now, at the advisory board, we have a lot of data, over a quarter of all inpatient admissions in the US. If you can win an election on 3% data, what could we do with 25? So we started putting all that data together, and you do get some pretty dramatically large numbers. So over 2 billion medication orders. And from those 2 billion orders, over 1 million names of drugs being dispensed. The thing is, you and I know that there's not 1 million drugs out there, so what's happening here? Well, it turns out that physicians speak dialects of the same language. Just like you and I sound like where we grew up, physicians use different names for drugs based on where they were trained. So let's look at a very real example of this. On the left-hand side, what you'll see are all the different names for the same cholesterol medication. On the right, the same CT scan. Now, for a computer, this is really hard to make sense of. And yet, in this, we have our big data opportunity. Because if you have lots and lots of names, what you get are tiny slivers of insight across your data. But if you could generalize, if you could ask profound questions, well, that's how you get big results. And so that's exactly what we tried to do. Over 1 million med names actually collapses to about 8,000 distinct medications. What we did is we looked across the nation and said, what medication trends can we find? That was our big question. And it turns out there's some pretty amazing stuff happening in this country. There's this drug called enoxaparin. It costs 40 times more than the alternative. And yet hospitals in this country are using it on 60, 70, as much as 95% of all patients with COPD. And it turns out that it's driven entirely by physician choice. So there's hospitals where enoxaparin isn't widely used, but the physicians who did use it did so overwhelmingly. And by the way, that 2 billion medication orders I told you about, of it, only 20% of it actually would give us any useful information about which physician was actually trying to order that drug. We didn't bother trying to complete this data set. Remember, time to market trumps completeness. And finally, if you look at the hospitals where enoxaparin is actually widely preferred at the whole hospital, virtually every single physician at this hospital is using this drug in very large quantities. That 40x cost I just described, that's what you and I, as healthcare consumers, are paying. Simply normalizing the name of a drug gave us that analysis. There's lots more examples like that in our data. Imagine what kind of profound questions we could ask if we could generalize more of this data. And really, the point of this talk is, this is the point of big data. It's not to enable you to ask a million tiny questions. It's so that you can ask big, profound questions. That's how you get big results. Thank you.